I would like to introduce Martin Chaov and quickly tell you, because in the morning I asked Rad, okay, please give me some hints how to introduce Chaov. And he said, this is a hardcore technical guy, one of the best JavaScripters in Bulgaria. Also, he's one of the most experienced speakers, so let's put him first in the agenda. He will handle any crisis in case this happens. So please, round of applause for Martin Chaov.
Okay, so no pressure. I am missing my dongle, which was here a few minutes ago. No, this one. Somebody took it away from me. Тя е автоматична, задръж. We are experiencing technical difficulties.
This is exactly what we meant by Chaov can handle anything.
Actually, Rado handled it, but I'll take the credit, it's fine. Okay, so no pressure, the introduction was very nice, thank you. Yay! So, good morning, good not morning, let's say. This is a very tough topic because I live in this kind of environment constantly. This is my life as an architect of SBTech, which is actually a pleasure to be in that team. And we are facing quite a lot of challenges because we've been on production for a while. I'll be talking about this a bit later, but anyway, the goal for today is to talk about how we do that. So we have a solid foundation of something, and we want to put something a bit more modern on top of it. And, you know, sometimes it works, sometimes it doesn't work so well. Do you guys know what is legacy software? Legacy system, for example. A few guys said, yeah. Okay, so legacy is a gift from the past for a better future. To put it in a different way, anyone seen Blade Runner, or your guys are too young? So this is one of the most beautiful scenes in cinema history. But basically working with legacy is to know the fear of actually relying on something that you don't know how it works. However, how many of you consider themselves working with the legacy system of any kind? So, just a few guys? Most of you are doing new stuff? Does it work? Like, all right, there is a guy, you know this guy? This guy created C++. So one of my favorite quotes from him is that legacy code often differs from its suggested alternative by actually working and scaling. So in order to continue in a way that we all understand legacy in a good way, let's first list what is a legacy project for us during this talk. Legacy project is any project on production. That's it. If it's on production, it's already legacy. Literally, like, that's it. So, let's first give you the perception where I'm coming from. What is my reality, what I'm dealing with, And then I will discuss how we solved it, the challenges and the errors that we made. So we've been on production for more than 10 years with the same software. Okay? How did that sound? Pretty scary, I heard. Yeah, we have VB-script in places. Do you guys know what is VB-script? It died a long time ago, but we still have some code actually making money in VB-script. We have XSLT even somewhere hidden. So today we're serving 20,000 plus live events per month. I don't know if you guys are interested into sports betting, but in short, in the next 48 hours, today and tomorrow, basically, there are going to be almost 2,000 different live events. Sport, like everything. Football, basketball, tennis, even golf. There are actually people who follow golf live. I don't know why. There are this kind of people. Then we are actually serving millions of users because we are a platform provider. So we are actually serving the customers of our customers. And do you guys think our system could do this 10 years ago? No, it didn't. This system evolved into doing this. So when we started, we were not serving 20,000 events. We were not serving millions of users. We had one site. And that's it, like almost nothing. So our system evolved during those 10 years. And this is why I'm talking about integrating newer technology into a legacy project. Because the dream of actually rewriting your entire software, remember, we were writing 10 years worth of code. Do you think, how much time do you think you are going to need to migrate this entire ecosystem into a new platform? Is it going to take 6 months? No, that's ridiculous. Is it going to take you 3 years? No. It's going to take you even more than 10. Thank you for that. So it's going to take you even more than 10 years. Why? Because when you have a system on production, you're actually actively maintaining this system. When you're serving millions of users, you're actually maintaining their needs. When you're working in regulated markets, you actually need to maintain the regulations, so GDPR much. You understand? We cannot go to production. We are actually on production, but we cannot not implement GDPR because we are going to implement GDPR. Kopć. GDPR. I guess that's why I'm first. The guinea pig. So, as I was saying, we cannot not implement this, meaning that our existing production code base is always going to be developed and increased. So any team that actually tries to recreate our software is going to be actively racing against the other teams who are actively maintaining and extending the older system. So obviously we achieved this with a very nice monolith because we were a small team, it was fast to develop, it's very much like performant, let's say. So today we grew a lot and we cannot continue developing the same way, but I'll touch this a bit later. Now, in the time when we started our project 10 years ago, do you guys know where the Node.js ecosystem exploded, roughly? Okay, it exploded somewhere around 2009 with the first demo release of Node.js. Package manager, I think NPM, first version of NPM was something like 2011. We were already making shitload of money on production. There was nothing like this when we started. So we had to implement our own custom package manager. So this is a challenge for us because our front-end code is packed by our own scripts. Then we have constant ongoing feature development, so we cannot just stop delivering. Something needs to pay our salaries. And then we have this very, very cool CMS. So it's not a user-friendly CMS, it's a developer-friendly CMS. So you can do a lot of damage with it. But basically, and this is going to become important a bit later. So what we have in our CMS is we don't really have pages. We have the notion of a page, what is a page on the web, but we don't really have a page like a static entity. So we create pages, and you have panels inside those pages, like left, center, right panel. And then inside those panels, we arrange blocks. So the block entity is the important entity in this talk, and it's going to become much more important later on. So with the CMS, it allows us to actually create any page that we want. Did I mention everything is developed by happy free-range developers? Okay, so let's start with what didn't work so well. So in the beginning, when we started with this entire TypeScript, React, Mobix, whatever ecosystem, the main problem is that we continued using our old mindset. So we tried to embed it into our existing workflow, and we failed. It didn't really work well with our package manager, so this was a huge challenge for us. Then we realized we just cannot make it work. It's not worth it. Some key points that we took from this is that React is really nice, really fast library. Like, it's amazing. Even when you write bad code in React, it actually works better than bad code written in native. Actually, even good code written in native. So this is amazing. Like, this blew our minds. Second thing is, don't forget the keys. If you mess up the keys, you're going to mess up your application. Like, literally. Just, you need to have unique keys. Don't use the array numbers for the keys. It's good for to-do list demo. It's not good for any other software. Just a short example. Have you guys seen a sports betting website? Yeah? There are lots of numbers in small boxes, which are buttons. So imagine I have football and then I have basketball. And when I move from football to basketball, the buttons stay the same as from the football. Why? Because the keys didn't change. Why? Because I was cycling from 0 to n. So if I had 10 soccer events and I had 10 rows, all the odds are sitting there. Then I move to basketball and I have 12 events, which is fine. But the first 10 rows actually maintained the prices for the soccer bets because the keys didn't change. So actively using array keys is just not an option. Something else that we understood is that in the package JSON, this should be a forbidden symbol. This literally means that you're going to get the newest compatible version. No, you don't. It's just not like that. Breaking changes constantly. Something else, separate the bundles. Now, with Webpack, because we're using Webpack, we can get code splitting, which is a really cool feature, uglifying, yada, yada, yada. The problem is that when you start developing n number of features which are enabled in different times on different customers, you don't need to bundle everything together. But this is what we did initially. So it was not a good idea. So we needed to define a build which actually builds separate features. More on that a bit later. Another problem, top-level imports. Top-level imports are the most important thing that you can do. The moment you start importing from inner folders, you're actually creating dependencies to specific namespaces, and they gather their own dependencies, and these get injected into your bundle. This is something that we realized when I saw that I have 3 megabyte bundle for something like a to-do list. Imagine it. Wow. And there are other challenges that we faced. So we faced challenges with people, actually. So our guys needed preparation. We didn't invest enough time into actually preparing our guys for this technology stack. So this is a mistake that we did. Also, observable properties don't work like you think they work. So just read the documentation. What do we want out of this? So where I'm getting at. So we want to get good development framework, let's say. So we don't want to build second monolith. We already know that. We don't want to interfere development between teams. Now we are no longer 5 people, we are 10, 12, 20 teams, it doesn't matter. Every team should be able to work on its own without interfering with the work of others. We don't want backend, that's important. Right now our backend is going into microservices and APIs. So we don't want our frontend to actually be tightly coupled with any backend. We want to have this kind of clear separation, so we are going to be able to put our new feature set on any type of backend, any type of data. So we don't want routing. I don't want features to know what other features are on the page, only messages. We don't want authentication. I don't want every single one of my features and every single one of my developers to implement authentication in their feature. No, we don't want that. And we want mocks. I don't want to build and run the entire set of microservices, the entire set of APIs that I have, just so I can display 5 events. I don't want to do this. I want to be quick and easy. What I want out of my artifacts, the artifacts are the output product of this framework. What I want of my artifacts is that I want them to be small, gzipped, uglified, minified, whatever, but small. 9 kilobytes gzipped is a big file, just so we're clear. This means you wrote 100 kilobytes of code. Wow. Shared common logic. Now, this is important because when I'm developing features separately and they're shared the same logic, I don't want my developers to be redeveloping the same stuff over and over again. So I need to export this somewhere. So I'm putting it somewhere else. Then I want them to be consumed from CDN. Why is that important? This is important for me personally and for our company because when I go to production, I deploy microservices, APIs, gateways, Nginx are configured, yada, 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 clusters, so on, so on, so on. And I don't want those artifacts to be somewhere in that mess. I want a simple CDN, serve the files, that's it. My core library is a concept where all the shared stuff is going to go. We are talking about atomic components. Like, I have the same button all over the site. I don't want 20 different implementations for that button. I want the same button. Helper functions, for example, date parsing. I don't want every single component to understand date and how to parse time zones. This should be exported. I want to manage dependencies, and this is actually very, very important. If you're doing distributed development like we're trying to do, package version management. How many of my projects are going to have different versions of React? None. I want one version of React. I want one version of Mobix. I don't want to be in a situation where my projects depend on different versions of different frameworks. That's terrible for us. And other stuff like that. Okay, so do you have any questions so far? Yeah? No? Okay, continue. I want to enforce quality gates. I want to enforce good practices for building, testing, linting, and so on and so on. I want to have configuration package. The way I'm going to enforce the same build process, the same linting process, and the same testing process, I'm going to do with configuration package. This package is going to be installed the same way as the core library. It's an npm package, so your project depends on it. And if you do local changes, Jenkins is going to actually install the fresh package, so you cannot do anything. I want this to be versioned. So if I decide I'm freezing a certain block to a certain build, I'm going to freeze it and forget about it. And obviously I said it needs to be installed. This package is going to handle build, test, lint. Technology is failing me today a lot. All right, interoperability. So what is interoperability? I want my artifacts, my blocks that I'm developing to be installed as plugins to my application. Now, plugin is a very nice word. The idea means that you're basically installing something somewhere and it works. This is why I want them on the CDN. This is why I'm not distributing them together with the application, because I want them to work as plugins. In order for them to work as plugins, I need to start abstracting away. So you basically abstract the abstraction until it starts resembling some other thing that you can abstract. So you abstract this thing, and then there are many abstractions talking to each other. And then you start understanding modern art. So suddenly, we realized that our CMS that I was talking about earlier, the block entity, actually is any object with certain amount of methods, like init, activate, deactivate, navigate to, set params, something simple. So any object, literally, any object literal created in JavaScript that has those methods can be used as a CMS block. So this is my abstraction, this is my API that I'm creating to talk to my old application. Then, after I have this common interface, I can patch my application a bit to actually accept those artifacts, and I'm basically done. This thing, how many of you know inversion of control as a means to make entities talk? Seriously, guys? Okay, dependency injection. Okay, so basically you implement inversion of control through dependency injection. Inversion of control means that my entities are going to know about some abstractions, but they don't know what are those abstractions actually. So if you're doing OOP, imagine it like passing instance of another class to your class constructor. So you basically know the interface, but you don't know what is the entity providing you those methods. Make sense? I'll show a very small amount of code at the end, and it should be much clearer. Then, I want to have continuous delivery, continuous integration, whatever you want to call it. I want to push a button. Jenkins starts working. I get more coffee. All right, so these are kind of my goals. This is what I want to achieve, and this is how I achieve it. Now, the architecture overview, a disclaimer, don't get into words. Words have almost no meaning if they're out of context. So I've named some entities, they have names, but don't get into the exact meaning of the words because those words may change depending on the implementation that you're doing. So, we already talked that we want the data to be separated and the UI to be separated, and we don't want backend. So we have this kind of architecture. This is my configuration package, this is my core library, this is the legacy system. Any project that we are doing in this space has three main entities. One is data, second is parse, and the third one is the block itself. The block itself is the entity that is going to be exported after the build process and consumed as a plugin from our CMS. So, what is data? Data is basically the dirty layer. This is, if you imagine an onion ring style of architecture, this is the outermost ring. Data is going to be actually communicating with any legacy names. It might know about legacy names. So this is important because in our system sometimes we have entities we cannot just rewrite as API, like start using this API. It doesn't work this way. So in the data layer we are going to actually be implementing dirty logic. We are going to know about stuff that we shouldn't know of. Then the data itself, since we are going to be using reactive programming approach, the data itself is going to have some observable properties. And that's it. No callbacks, no event listeners, no registering, subscribing, unsubscribing, and so on. Data has observable properties. Then we have the parser. Parser is the place where we're going to implement our business logic. Now, this business logic can be anything. This is why it says just parse. I don't know what is the business logic in your case. But you can imagine it as a simple CRUD application which applies some models to the data, which is observing. So parser observes the data. When data observable properties change, parser triggers. So parser gives us extract, transform, load operations, or simple CRUD, applies the models to the data, so we get typings. We're using TypeScript. And then we move to the block. The block has state store and UI. That's it. Okay, expanding. So how the exact integration works is that my legacy talks to my block, and my blocks talk to my legacy system through this core library. This happens like that, simple, with arrow. Then the integration which is providing the init activate, deactivate blocks does some magic. It activates the state store and the React component. It activates the data and the parser, passes it to the React component as a state object, and that's it. Simple as that. If I need to show you the code is looks almost like this. So we have the base block entity, which is coming from my core library. It provides me the integration that I need. Then I have the UI, the data, the parser, and the state store. What I'm doing, so this is basically the inversion of control. So I'm creating a data instance, I'm passing it to the parser, and I'm passing it to the state store, and I'm passing the state store to my block state, whatever object. Simple as that. This way, I have clear separation between the different layers, meaning that if my data layer changes because my backend is constantly evolving, I will touch only the data layer. My business logic, in this case, is always going to be the parser. And this parser is not necessarily going to change. Even if I have breaking changes in the data, I can maintain the same observable properties. I can maintain the same contract between them. So this way, I can change the entire data layer and all my code is going to continue working. I can move from push to pull or from pull to push, whatever I want. Same thing goes for the block itself. This is just presentation and state of the presentation. I can write many different types of presentations for this business logic, and it's going to work. It's going to be nice. So this architecture actually has different variations. Let's say, yeah? It's not DI. Yeah, this is why I said, yeah. Yes, so this is a good point, but I didn't say this is dependency injection, I said it's inversion of control. There is a difference. So furthermore, this file is the integration file. This is done here. This file is actually what provides you the integration with the legacy system. And this is where you need to hook up everything. DI, to implement real DI in TypeScript and JavaScript, you need to actually create something that parses your code, understands the function signature, because there is no function signature. You need to parse the entire function as a string. Then you need to understand what parameters are passed. Then you need to have global registry of those parameters and then do some code that actually sends them. And this is one of the main reasons why AngularJS failed and they're rewriting it not to do that. So, yes. Okay, the question is actually very good. Why the names are not following any pattern? First of all, because MVC is a stupid pattern. MVVM is a stupid variation of MVC. Because there are no models and controllers anywhere here. This actually follows something that is called domain-driven design. It's applied as a three-tier architecture on the client. And this architecture is mainly used during development. So there are a few pieces that I didn't mention. The integration file is actually a dirty file. This file knows too much and it is compiled in different ways based on the fact that you are going for production build or for development build. So this file has a lot of magic happening here in order to enable this entire system to work. The reason why those are not called in any specific way is first of all because I hate when I open a project and I see three folders, models, views, and controllers. What does this application does? What this application does, nobody knows. It has some models, views, and controllers. So I need to start actually reading all the controllers to understand what is happening. And this is the reason why in the beginning I said, don't take the words, take the meaning behind them. This is what I want. I want to have a domain which parses my business logic. I want to have domain that provides my data integration. I want to have domain which is, I don't know, carousel. The point is that when I open each of those domains, and those domains need to change their names based on the project. So this is a template. You don't write a folder which is called data, and you don't have a folder which is called parse. You have folders that actually reflect your application. When I open your project, I need to understand what this project is about, not that it has some controllers. Actually, when we're talking about MVC, I want to ask you a question. Maybe we're going to discuss it later. Think about it. In a classic MVC pattern, where is the business logic? In the model or in the controller? We can discuss why. The data can be adapter or facade. Yes. If you decide to implement them as facade, adapter, and services, you can call them like that. That's the point. But I don't want... Problem with patterns is that when people see a folder which is called facade or data facade, they really are going to try to implement a facade. Even if facade is not good enough, they're going to literally break their code and logic around just to be able to implement something that resembles a facade. I don't want that. If this is a data facade, call it data facade, that's fine. As I said, this is a template. If your business logic is ETL, call it ETL, call it crude logic. You can actually have folders which are create, delete, update, whatever. You can create any implementation here. You can use any patterns here. I don't want a carousel block, which is scrolling left and right, to be implemented the same way as my I was going to say betting slip, but think about it as a checkout, pazarska kulička, checkout basket, whatever. So I don't want to have the same structure for my checkout as I have for my carousel. It makes no sense. Each project needs to have its own architecture. So these are, I understood that I have 3 minutes. So these needs to be a template for you guys to think about the business logic of your application, to understand what you can abstract away, what is going to be your dirty stuff. Okay, let's move on because I have less time. So this architecture can actually have different variations. You can use the same business logic and data layer for different blocks. So as I said, I have carousel. I can have 10 different variations of the carousel. But if they're using the same data, they don't need to be re-implemented into different projects. They can reuse the same. Also, I have a pattern where I can move out the state store. So the state store can actually be consumed from the block, and it's the same type of state store. For example, I have carousel that is consuming the same data, uses the same business logic, basically uses the same store, but the presentation is different. And I don't want to have one React component where I have if-else, switch case, if-else, switch case, and so on. Then also I can do that. So this architecture, as long as you're not crossing boundaries, as long as you're not getting from the block directly to the data, as long as you're following the same flow from data to presentation, it's fine. So quickly, pros of the architecture, it gives you clear separations of concerns. It's kind of technology agnostic. I want to write React, okay, write React. You want to write Vue, okay, write Vue. Nothing tells you in the parser you're thinking in React. Nothing tells you in the data layer you're thinking in React. The only place where you're thinking in React is actually the Vue. Since we're using TypeScript, you're kind of bound to it, but anyway. Code reuse, this actually enables you to reuse code across different features, and it's resilient. It means it resists to change in a good way. You cannot easily break it. Something changes in the data layer, as long as you keep the same contract, you actually get the same result to the view. some cons in the beginning, as one of the guys said in the audience, it has harder adoption. People need to actually understand that this is a template and that they need to actually think about what they're going to be implementing and change it according to their needs. And the second thing is it has complicated initial setup. You need to actually set up, if you don't want to go to the public repository, you need to actually set up your own internal repository. You need to publish your packages, consume them. You need to manage their versions. And actually, in order to make this easier on our side, we actually created scaffolding command line tool where you can just write a few commands and it sets up the project, gives you the basic entities and so on. So, questions? No questions? There are 2 minutes.
So we told you we were full of surprises. Actually, we're going to experiment with a funny format right now. So I would like to invite Chaov together with Rado and Krasi to have something like a Q&A comment session on the talk. Do your magic. Okay. Ah, okay.
Can I sit or
yes,
I should
please.
be standing?
You need the mic, right? Just a quick request to all the speakers. When there are questions from the audience, can you please repeat the question before you answer so that we also record this and also the audience can hear?
Yeah, I forgot about that.
No, no worries. I forgot the instruction. So, you know the rules, right? Basically, they came up with this idea, so I count on them that they can handle it.
Hey everyone, yeah, I think I kind of know what's this about. So you mentioned that you tried integrating React into your legacy system, but it didn't work. Then I guess at some point you had to basically sell React to the management team. How this happened? How did you like convince them that this is like the right decision?
Yeah. First of all, they had to convince me because I didn't want to use React. I wanted to move with Polymer and web components, but that's a different topic. The first reason why this didn't work is that we tried to actually implement it into our existing workflow, and we have a large .NET application, meaning that we had to integrate the npm install, package management, and so on into our .NET solution. So when you run build, it needs to, if you don't have Node.js, it shouldn't fail. It needs to install Node.js, so you're downloading NuGet. Then this NuGet actually starts doing the npm install, so then you start actually downloading and installing. It's crazy. So eventually we needed to move to a different kind of setup that does not interfere with ours. About the second question, it was actually a very tough process to select React. We were doing proof of concepts for about 2 years before we selected React finally. We did POCs with Polymer, with web components, we did with AngularJS, we did with Angular. It was still better than the Angular 2. We identified many issues with all the different libraries, and React, especially in the configuration that I showed, is actually the easiest one to use and the easiest one to change. And I'm not meaning that I'm not trying to say that I want to move away from React, but if I get breaking changes in React itself, let's say React 18 has huge breaking changes with React 17. They decide to brand it something else. How do I move my architecture forward? Remember I said I'm talking about application which is 10 years old, and it's going to have at least more years, more tens.
If you're lucky.
If we're lucky. And we don't count so much on luck as much as on professionalism, but the point is that this application needs to evolve, and I need to provide a framework that is actually going to help us evolve.
Yeah. How long did it take you to like, okay, we start this new system and then integrate it with the old system, and are you kind of done or in the middle, or what's the status there?
Well, right now we are on production with what I showed you, so we know it works really well, even when we are treating it badly. What is important is just don't forget to write the tests, include them into your workflow. For example, in our workflow, I am striving for code coverage of 80% at least. I'm talking about cross branch coverage, function, statement, line, everything, at least 80%. And over time, it showed us that this is the good approach. When you come back to a project 6 months later and you update something or try to fix a bug, the tests are priceless. This is your documentation, basically. This is what tells you how the code should work. In terms of transformation, this is going to be a long transformation for us. This is why the framework must be flexible, because we need to be in a situation where we are going to include new technologies over time or change technologies over time. So what we do is we actually export all the third-party dependencies as a separate package with separate version. Then we have our core package, then we have our configuration package, and we have our scaffolding package. So you don't manually create projects. Creating a project is an automated process. It automatically gets CI, and really when I click a button, it goes from the master branch directly to the CDN packed with the version.
Okay, yeah, that's cool. We are a bit out of time. So the goal of this panel is for like us, the speakers, talk with each other and discuss all the stuff. And for you, just find Martin in the coffee break. He's really great at explaining stuff, as you already saw. And yeah,
Thanks.
we'll be continuing with the next talk immediately.